Welcome back after the lunch break. Now it's time for the last part of KCD Austria 2024, and we're going to start with a real blockbuster, with the godfather of observability, Juraci Paixao, principal engineer at Grafana Labs, who is going to give you the overview over the history and all the use cases of observability. Let's have it for Juraci.
Thank you. Hello, everyone. Before I start, I'd like to first recognize the work of the organizers here. So this is the third day, as I understand. We had a first workshop day and then 2 days of presentations. And organizing an event like this is not easy. And so I'd like to ask you all, a round of applause to the organizers of KCD Austria. Yeah? So for the next 30 minutes or so, I'm going to focus on observability. So that's the area that I've been involved in for the past, I don't know, couple of years, perhaps a little bit more than a few years. But we have a lot of noise coming from different directions, telling us, you need to use OpenTelemetry, you need to use Jaeger, you need to use Prometheus, you need to have observability 1.1, 2, 3, 5.0. So that's all that you have to have. Now, we kind of forget why we are doing this, right? So this is the purpose of this conversation here. So it's not very technical, although I would say it is technical enough for the conference here. So a little bit about me. So my name is Juraci Paixao Kröhling. I'm a software engineer at Grafana Labs, and I'm also part of the governing board for the OpenTelemetry project. I'm a CNCF ambassador, and as a software engineer, I maintain a few modules of the collector. I'm also very proud to be the author of a few tools, such as the OCB, OpenTelemetry Collector Builder, and the operator. Anyone here knows the operator or OCB or uses that? Cool, nice. Yeah. All right. On a previous life, I was a maintainer of Jaeger and OpenTracing before becoming OpenTelemetry. Now, as I mentioned, we are going to see, we're going to take a step back and go, 10,000 feet and see why, how did we get here? So why do we need observability in the first place? And it all started with the Agile movement, or even before that, right? So before Agile, we were doing something that now we call it waterfall. But I remember that being called back in the day SDLC, like the software development lifecycle, right? So this was a state of the art, like 25 years ago. I don't know. I think I'm old. But some 25 years ago, it was like the state of the art. The idea was business analysts would go to users and ask them what they need. They would draw like mock-ups on a piece of paper, and they would translate business language into programmer's language. And they would get this document, this set of requisites to architects. And the architects would then draw like beautiful UML diagrams so that people could then understand what they have to build. And they would split parts of the UML diagram into departments within the company. Each team would implement a specific part of the UML diagram. And it was beautiful. Sometimes it was even printed out, right, in huge papers, and in huge maps. Now, after that was done, after developers finished their parts of the system, they would give that code to the quality assurance department. And the testers would then test this system by clicking on things and trying things out as they were specified. And if everything worked out, after 6 or 9 months, after the initial conversation with the business user, they would get a CD burned with the software that was supposed to be running in production for them, right? So they would ship a CD, like a physical media, or perhaps even a zip drive for those that are perhaps of my generation. Now, that one would then go to the client, and they would install on their systems and run it, and then they're going to find issues and circle, and it goes back again. So the problem is, we have a very large development cycle. So we have like 6 to 9 months until that user got a feedback on what they wanted. Now, 6 to 9 months later, things changed, right? So people wanted to move faster than that. So that's the context for the Agile movement. So some people thought back then, this is not we should do better, right? So we can do better. So they came up with a few tenets for the Agile movement. And so it's a beautiful document, like the Agile Manifesto is very nice. It's a historical piece of text. But if we can split that document into some tenets, those would be, right? So first one is we take an iterative approach to development. So we don't spend like 6 to 8 months doing first doing all the planning and then all of the development, all of the testing and the deployment. We do small chunks at a time. We have cross-functional teams. So we now, before we had like business analysts and architects and software developers and testers, but now we have a small team or smaller teams that are cross-functional. So we have front-end people with back-end developers and PMs, and they are talking to users all together so that they can all understand what's going on and so on. We have very fast customer feedback loops, so they don't wait 6 months. They see the result of the work after that iteration, after that development iteration. Some people call, like in Scrum, people would call that like the sprint, but it doesn't really matter what it is, right? So the point is the business users would get the results very, very fast. Now, those that are from my generation, you remember that when change came from the user at a very late stage of the development cycle, we would be mad. We would be telling them, how dare you change the specifications now? The specification was done like 6 months ago. I'm developing based on what was written and signed by you back then. How dare you change it now? Now, with Agile, we changed the mindset. We embrace change. We embrace by thinking that change is evolution. So things have to change and things have to evolve. So that's the idea behind embracing change. And as I said, deliverables are functional, meaning that whenever we are done with the work that this iteration, we have things that are functional. We have things that are that provide value to our user. Now, this is all nice and good on paper, but how does that translate into architecture, software architecture? And one of the results of the Agile movement was the application of the same concepts into the software architecture that we now know as microservices. Of course, it wasn't like we have Agile, now we have microservices. It was very a path going there, right? So it was an evolution as well on its own. But microservices, they do assume some of the same tenets or philosophies of the Agile, so we can make some parallels here. One of them is we have this idea of decentralized and independent services, right? So we have now services that that can be managed separately. And so I used to work at a company in 2009, 10 perhaps, and we were doing a payment processing system, and it was a monolith. Now the problem is, whenever we had a bug on the subscriptions endpoint, we were affecting the performance of the payment endpoint, right? So I mean, when we look back now, the payment endpoint is way more important than the subscription endpoint. So why should they be tied together? Why should they influence each other? And this is where microservices can help us. So microservices we can have one deployment or one endpoint for the payment services and have its own HA, so its own high availability scenarios. And we can have for the subscription service perhaps fewer replicas or fewer instances running. Perhaps I don't need such a big machine for that specific endpoint. And that is made possible by microservices. We have a loose coupling and a high cohesion in the system. We have a scalability and flexibility, so we can scale up and down the things at will and based on their current needs. We have faster deployment cycles. Again, if I have a bug on my subscription service, I don't have to wait for the payment endpoint to be ready to ship my bug fix. I can just deploy the subscription service without having to even think about the payment endpoint. And as a result of that, we have resiliency and fault isolation. So if one endpoint breaks, it shouldn't bring my whole system down. Now, going back to the Agile movement, we have the same concepts being applied not only to the architecture of our systems, but on how we run our systems as well. So it gave birth, or it started this whole DevOps culture. or the DevOps movement, right? I need some water, sorry. Yeah, so we can apply the same kind of ideals from the agile movement to DevOps, right? So DevOps is not like devs doing ops or ops doing dev. Of course, you know that already. But the idea is we have a, back then, when devs had a specific need, or when they had a new version of their systems, they would come to ops, which back then they were called the sysadmins. We would go to them and say, I need this software here deployed, my new version of my software deployed there, but I need a newer version of the MySQL client there. And the sysadmins would not be happy, right? So they would look at me and say, no, sorry, a new version of MySQL client, that affects everyone in here, so we're not going to do that at all. So there is this conflict, the wars between devs and ops. Now, applying the ideals from the agile movement, we now have some change. We have to embrace change, right? So we have to move faster. We have to assume that a new version of the MySQL library is going to be needed. Now, how do we ensure that that change does not bring our services down? One of the key things of the DevOps culture that we embrace today is the idea that everything is code. So configuration as a code, infrastructure as a code, everything is code. It's not like we set up a machine that's working, we don't touch it anymore. Right? So that was the previous understanding. Nowadays, we have everything documented as a manifest or as a recipe somewhere, and we can then change that recipe whenever we need a change. We change the recipe, we apply it in development, we apply it in acceptance testing, and then we apply in production as well. So again, faster feedback loops, embracing change, and but one of the things there is we need reliability. We need to make sure that the systems are reliable. And that specific point, reliability, gave birth to a discipline on its own, and that's the reliability engineering. Right? So you might have heard about a book called the SRE book from Google that defines this whole new discipline. And the idea there is so breaking down, you should read the book, right? If you haven't yet. But if we break down and summarize the book in 5 points, I would say that one of the key things is resiliency. So we think about resiliency, and what does it mean here? So resiliency here means that once we have a code that is ready from the business perspective, we get it in front of a reliability engineer, which can be even the same developer, and goes there and change the mindset. Now I have to think, how can I make this software here more resilient? So what kind of code should I add to my code to make it resilient? Should I add a queue in here? Should I add a bulkhead there? Should I add some retries with backoff here? Right, so that kind of thinking goes in place as part of the development process, and it belongs to reliability engineering. Now, because we now have multiple microservices, we have multiple versions of the microservices, we have to rely on automation. So automation is key. We cannot just deploy new versions. We don't have like 3 servers anymore where we deploy everything on those 3 servers. They're our pets. We don't have pets anymore. We have like a huge number of services that we have to take care of. And we cannot do that manually. We have to rely on automation. And how do we know whether we are doing the right things or not? How do we measure how successful we are doing? So we end up now with this notion of error budgets and SLOs. So we specify our targets for the operation, so our service level objectives. So we say that we need to be, we need to respond to our users within 100 milliseconds, 95% of the time. So that's our SLO. How do we make sure that we are not breaking our SLO? We start measuring that. We start adding SLIs, so service level indicators, metrics basically. And then we track that over time. And at the beginning of the month, we have a budget of, if our budget is 95% of the time, that means we have 5% budget to be above 100 milliseconds on the example before. So our budget is 5%. If by the end of the month we are at 6%, then we failed. And if we are getting close to those 5%, then we should stop innovating and start working on bug fixing and things like that. If we are always at 100%, like 0 downtime, then we're probably not innovating fast enough. Then we can probably not break things for breaking things purpose, but we can innovate more, and with innovation eventually comes things not working the way that we expect. So the latency can be a little bit higher, perhaps our services will be down for a few minutes, but the idea is we have data to determine whether we are within our parameters or not, and that's key. We have to plan for scale. I'm not going to touch too much there, but the idea is we have to, before going to production, we think on what do we actually need to launch this here in production. What kind of traffic do we expect? How many users do we expect? And what happens if we have more users than expected? Now, people from my generation might remember the slash dot effect. So the slash dot effect is something that if a website, if my system was featured on slash dot, a news site back then, it was very normal for sites to go down, and that was a slash dot effect. Now, nowadays, we might be proud of this slash dot effect, or we were back then, but nowadays it's not acceptable to degrade the performance for all of our users just because we have too many users. So how do we deal with that? And that's planning to launch for at scale. Now, all of that, you might have kind of got the hint that all of that requires data. All of that requires understanding our systems. Right? So everything here is tied to the telemetry that we need from our application. So that's where observability comes in. Now, observability, or OLI, for the people who are close to the matter, is the ability to find answers to questions that we don't have yet. All right. So now, some people might say, well, isn't that monitoring? And no. So monitoring is a little bit different. So for monitoring is the practice of obtaining quick answers to frequent questions. So in monitoring, I know the questions that I'm asking upfront. Typically, I have a dashboard, and on that dashboard, I have answers already for me. So what is the CPU usage for my fleet of servers? What is the memory consumption? What is the latency? What is, perhaps I have a red dashboard, right? So request, error, and duration. So those are questions that I had upfront, and I encoded the answers on my dashboard, and I can have quick answers to my questions just by looking at that dashboard. Observability is when I need answers to questions that are not on my dashboard. So when I'm paged at 2 a.m., or as someone told me yesterday during the reception, when my systems go down and when I have an outage on the wrong day, as if there is a right day to have an outage. So when we had an outage on the wrong day, I need to be able to understand what's going on and come back as soon as possible. So that's observability. Observability allows you to, or observability is a technique that we use to understand what our systems are doing by making use of telemetry. So what is telemetry then? Telemetry is the data that is generated by our application informing its state while it's running. So I don't have to touch my application to understand what's going on. How do we do that? Typically, logs, right? So when I started, we had only logs. We had print on our code, and that was our best debugging tool, right? So we would print the state of variables and how many times things happened, and that's valid. But it's not our only weapon of choice. We can have other tools in our tool belt. So besides logs, we have metrics. So metrics, they are aggregations of values. So we can answer questions like, what is the P95 for my latency from this service to that one service? So we aggregate all of the latencies, and then we place them in buckets, and then we can answer our question there. So we don't have individual points, individual latencies, but we have the aggregation of those latencies there. We have traces in our tool belt. So traces can tell us the story of a request as it goes through all different systems. So if I order a pizza on my phone, it certainly goes through hundreds of microservices at the back end of the company that is processing that order. Now, if anything goes wrong there, I can be shown, as a user, I can be shown an error code, and I can use that code to call the support for the pizza delivery company and say, I got this error code here. Now, hopefully, they would be able to look up that code and see exactly what happened when I pressed the order button. Right, so they would be able to see when it failed, why it failed. Perhaps the database connection wasn't available there. Perhaps some rollout was happening at the exact same moment that I type, that I press the button, or things like that. So that's we can get from traces. Profiles. Profiles are pictures that we take of our code, of our process at a specific times. And if we take enough pictures of our process, then we can tell a story. So we take a picture of the heap and the stack, so memory and CPU, and then we can see, we can extrapolate statistically and say, well, I took enough pictures to make a guess that that specific method is being called 80% of the time, or that the process is stuck there 80% of the time, and that is the state of the memory at, when that happens. Right? So we can really take a look at one specific process and understand it. And events. So events are things that are typically outside of my main service. So perhaps I have a new deployment, perhaps I have a new network topology, perhaps I have a new configuration for my service. Those are events that can be shown to me when I have an outage on the wrong day, right? So I can see that that day I had a deployment, I had a topology change. It's DNS, it's always DNS, right? So DNS changed at that day, and things like that. So those are events. Now, cloud native, where KCD, Kubernetes is almost the definition of cloud native. But if we take a step back and see what exactly is cloud native, then we abstract away from Kubernetes. So why do we need Kubernetes at all? So what is actually cloud native? So cloud native is a type of system that relies on orchestration. So I define, or I can tell, what is the system that I need, or what are the things that I need, and something, an orchestrator, Kubernetes, for instance, would then make sure that that thing is running, that is happening. What I want is happening there. So I have different versions of the services, perhaps, or I have a service that must coexist with another service on the same machine. It is all part of the orchestration. Now, not only orchestration is cloud native, so things are dynamic and ephemeral. So perhaps my systems can go from 0 to 100 in a few minutes and then back to 0 again without leaving a trace, so without leaving anything behind it. They are designed, so a cloud native system is designed to be horizontally scalable, meaning that I can have multiple versions of the services running at the same time on different nodes. I can just create a new cluster, just like the first one, and things should horizontally scale nicely. It's API driven, and perhaps more important, we rely on the resiliency and the self-healing aspects of it. Right? So basically, if something is not working, so I have a health check on my system, and I can detect that it's not working for some reason, I can just kill it from this machine and boot on another one, and it might be fine. Right? So I have that self-healing aspect to cloud native as well. Now, what it means is we need observability when we are dealing with cloud native architectures, because we have multiple versions of the same services running at the same time, because we have different clusters and different pods, and things may fail at different points of architecture. So things that we need to answer when we have a cloud native architecture are what happened and where. So which pod caused the issue that I'm seeing? In which cluster did it happen? And is it specific to a region, or is it widespread? So those are things that I need to be able to answer whenever I'm awoken at 2 a.m. To find out the cause of an issue. Now, perhaps I need to answer questions during the business hours, during a rollout. So perhaps I have a new version of my system going in, and I need to answer questions before proceeding to the next step. Like, should I proceed with the rollout? Should I go on with this update? So in that case, we need to think about that process beforehand and think about which business metrics do I need to implement on my application so that I can answer that question at runtime. Now, perhaps sometimes I need to know who am I talking to. That's the example of the pizza delivery before. Like, what are the interactions between the services as they are executed? So did I get into an error because service A on version 1 cannot be talking to the service B at version 2? It shouldn't happen, but it does. So that's something that I have to answer. I have to be able to see what is what are the consequences and the reasons for a specific failure. But I guess what I'm mostly interested at 2 a.m. is when I'm under-caffeinated. I go to my machine and I open the dashboard there and I see some spikes in the graph. I don't know about you, but what I think at first is, what is normal? Is that normal? Is that what I should be looking at? What is the baseline? And documenting the baseline is part of observability as well. So observability is not the telemetry that we create, that we put in our systems, but also helping us at 2 a.m. to determine what is happening, right? So the whole point, the whole idea of observability is this. Am I able to answer questions about my services when I'm paged at 2 a.m.? And if I am, it doesn't matter if I'm using Observability 2.0, if I'm using OpenTelemetry, Prometheus, Jaeger, it doesn't matter. What matters is I have a problem that I need to solve, and I'm using tools to solve those problems. Now, how puristic it is, or how sold I am to a specific vendor should not matter. What matters is this. That's it, and thank you for your attention, and I think we're on time.
Thank you so much. You're actually
30 seconds.
Yeah, under the time. Thank you so much. I mean, for me, it comes to mind intelligence in the sense that, being able to, the system basically talks to me, right? If they could,
Exactly.
is it that?
Yes,
Yeah.
absolutely, yes. Absolutely. In this time of generative AI, we can ask systems and hope that they are going to answer back to us what we need to know. Yeah.
And this is intelligence without artificial.
Exactly.
Are there any questions in the room? Otherwise, Juraci is going to be here. So please. Okay. We will repeat the question. I don't see where we're pointing at.
Yeah, so repeating the question, so if I have any experiences to share on the team organization when that move from monolithic to microservices happened. So I have I was at a conference when I was a Jaeger maintainer. I was at a conference, and after talking about Jaeger, someone came to me and said, I just want to say that Jaeger is awesome and that I use there on my company, and I was very curious, and why do you use that? Oh, because I sit on a service that is between another service and like two services. I'm sandwiched in between two services, and that service here, they're slow, and they claim that I'm slow, and that one other service is saying that they are not slow, and I'm just a proxy, so I'm not doing anything wrong. So what they did was they instrumented their services, and they installed Jaeger and on a server under their machine. And started tracing their application, so they could prove to management that my one here is not slow. The one that is slow is that one there. So here's the proof. Now that report got shared among the managers, and the managers then decided, you know what, this tracing thing is a nice thing to have. So let's implement that over all of the services in there. Now I guess the point is when we have a distributed system, we need to split into individual teams, but the culture of the company has to change as well. You have to change the way that teams interact. So from blame to fixing issues. And fixing issues is what this tooling, Jaeger was one example, but finding the tools that will help you shift from blaming one each other to solving issues, that's the key.
Such an important message. Thank you again. Do you want to take another one?
Sure.
Yeah. Then please speak loud, we'll repeat.
So the question is whether we should prefer observability over monitoring, right? Yeah. They are complementary. So monitoring. So the way that I work is. I'm not paged at 2 a.m. that often, but when it happens, what I do is I take a look at my dashboards. I look at so dashboards, they are a treasure trove of the things that I learned in the past. So everything that happened that cause me pain, I encode it as an alert or as a metric on a dashboard somewhere, so it is in there. So I look at those first, and I see, well, it's a quick way to find what is happening, right? But sometimes issues are new, and I don't know what's going on. So, and then I jump into my observability kind of experience to see what's going on in there. So I go into exploration mode. So I stop from looking at dashboards and understanding what's going on into more explorative approach. Now, they're complementary. I don't think about monitoring and observability on my daily basis. It's just tools that I use to accomplish what I need to do. There's another one, yeah?
Quick one.
Whether I anticipate a standard for the events that I mentioned. So events are complicated because they are so abstract that there are few standards out there already. So there are the cloud events is one such standard, and even within OpenTelemetry, we are converging the logging signal with events signal. So events in OpenTelemetry is basically logging with a few required fields, like the service, event's name and the event's namespace would be like the required fields within a log. But I think the point is they are abstract, and you can think of them as things that happen around my application, not necessarily like events per se, not logs or not a specific data structure.
All right.
Yeah.
Well, obrigado
Yes.
to Juraci. Again, big applause.